Good morning and welcome to our lesson today. We are still on light, and the light is a form of wave that we singled out in order for us to examine all the properties that we looked at with reference to waves. Now, today we will look at reflection by plane mirrors, and we appreciate that a plane mirror is actually a smooth surface. Therefore, we expect that because a plane mirror in itself is smooth, we will have regular reflection. Regular reflection of light. That is to mean that we will have an incident form of a beam, and this incident beam, which is actually very parallel, is going to be reflected in such a way that the resultant beam is also going to be parallel to each other in terms of direction. Intensity will also not be compromised because our surface is smooth. Remember that for reflection to occur, there are some laws that we talked about, and we said that the angles have to be taken care of so that we find out that angle of incidence, which we abbreviated as I, should be equal to R. I should be equal to R. Now, with this regard, I want us to find out how do we form images using plane mirrors. Now that we are well conversant with the terms that we are going to interact with regard to reflection, we have this as our normal. This one is the reflected ray. We have the incident. Then the angles that we are talking about, we have angle I and we have angle R. Now, we have some mirrors that will take care of these laws, keep these conditions, and obey the laws of reflection, and still give us some images. What you ought to realize is that for all images, they are virtual. For all images that a plane mirror will give us, we expect that the mirror will give us virtual images. Why do we call them virtual? By the way, a virtual image is one that cannot be formed on a screen. One that cannot be formed on a screen. You can't see it on a screen because when you shift your object, you automatically get rid of your image. It cannot be formed on the screen. Why we say that the images formed by plane mirrors are actually virtual is because the reflected rays, which are the ones that are supposed to result into the image that we are claiming, actually do not go through, they do not go into the mirror. Rather, they appear. They just appear. If this be our mirror, we have an incident ray, and this incident ray is traveling to the mirror. We have our normal there. Then we expect that ray is going to be reflected that way. Then what will happen is that this ray will appear to be originating from some point behind the mirror. Remember, this one is our mirror. We have an incident ray that comes to the plane here and is reflected in such a way that we keep to the laws of reflection. It will appear as if it is coming from some place behind the mirror. Now, if we had another one, so that now we have another one traveling like that, then similarly is going to be reflected at the plane. Again, it appears to come from some place. It will meet, the two will meet at some point behind the mirror, and this is where our image is going to be observed. Therefore, you can clearly see that the rays are not actually passing through the point where our image is formed. Rather, after reflection, they only appear to come from that point. Now, we look at characteristics of images formed by plane mirrors, and one of them is that the image is as far behind the mirror as the object is in front of the mirror. That is the first very important characteristic, and that one tells us the relationship between the distances, the image and the object distance relative to our mirror. Now, this is what we mean. Let us take an example of an object that is placed somewhere here. This is our object. And this is the object we want to view using our mirror, and we want that one to be by way of reflection. Now, there is one ray that we don't expect to be reflected, and this one is what we call the normal. Now, suppose we consider another ray from the object to the mirror and expect that this ray is going to be reflected so that it follows that path. Then we have another normal here, because we said the reflected, the normal, and the incident ray should always lie on the same plane. Then we have, so this one is going to be reflected through the same path because the angles have to be equal. Now, let us also consider another one to the plane mirror. We reflected in such a manner, and we said that these rays are supposed to appear to come from some place behind the mirror. Therefore, we extend We extend our rays. Then at the point where these rays are going to be to intersect, that is where our image is. That is where our image is. Now, the distance from the object to the mirror clearly is the same as the distance from the mirror to the object. That means that our object, if this one distance here if we call this one A, distance A, that is from the object to the mirror, we expect this distance also to be equal to A. We expect that this distance is to be equal to A. And even if you were to consider the three rays, where these ones are reflected, these ones follows the same path, you see that it will appear to come from some point also where the other two intersect. So it does not really matter how many rays you consider, all of them are going to meet at some point behind the mirror, which is equidistant from the object to the mirror, is equidistant from the mirror to the image. That is what we mean when we say that the image is as far behind the mirror as the object is in front of the mirror. That is what we mean by that. That marks our first characteristic of images formed by plane mirrors. Number 2 is that the image formed is the same size as the object. In other words, we can say magnification is equal to 1. Now let us see that by way of drawing. This is our mirror again. Let us put an object here. And we expect to view the image of this object somewhere behind the mirror. Now, again, we use our first ray, which is perpendicular at the point of incidence. We say that this one passes on and goes back undeviated. Remember, we still have some laws to obey with regard to reflection, and one of them is that the angles have to be equal. I has to be equal to R. Therefore, this ray is going to pass on undeviated. Let us take some 2 rays from the top of our image. Again, we are going to reflect that, extend it to some point there. We can have another one from the top to that point. When it is incident, it is also going to be reflected in that manner. So we expect that our object is going to have its top at some point there. Then we can have some ray from the bottom to the interface. From the bottom of the object to our plane, then reflect it also, extend it, and then we have another one here. You reflect that way, then you extend it. Therefore, the bottom of our object is going to be somewhere there. Therefore, we will have the image there. That is to mean that if the distance from the bottom, remember that magnification will be given by V over U, where V is the image distance, U is the object distance, and we said that here V is equal to U. Therefore, you expect this ratio to be 1. The same thing will be given by image height over object height. Should give you the same thing. That is why we say that for a plane mirror, our image, this one, this is the image, this is the object that we want to view. The two should have the same size. You do not expect a plane mirror to actually magnify your object. By magnification, we mean it can reduce the size or increase the size depending on these ratios. When we have a whole number here, we mean that now we have some magnification or some increase in size. But if you have some decimals, say 0.2, that is the ratio by which the object will have been reduced in size. Number 3 is that the image is laterally inverted. Laterally inverted. That is to mean that when you observe your image from the mirror, your right hand side will be your left hand side. Let us think of that with regard to some diagram here where we have a plane mirror. Again, we can have let us have, say, an arrow for an object. Again, we will have our ray that should not be deviated. Remember that this side, the arrow is virtual, meaning that does not actually pass through there. It only appears to come from some point behind the mirror on its return. Now, from the top, we can have a ray that way. Then we can have another one that way. These ones are reflected in that direction so that we take care of the loss of reflection, and we extend them so that now we have the top of our object at some point there. Then we consider an arrow from the bottom. At this point, we have an arrow. We have another one. we will reflect the same so that we have something like that. Again, we can extend up to where we have an intersection. Therefore, clearly, from this top part, the rays that emanated from the top were reflected to follow these paths that we will call A and A here. Therefore, A gave us the arrowhead of the image here. Therefore, if we are to draw our image, it will appear like that, so that now the arrowhead is at some point there, and then the tail of the arrow, it is at some point at the bottom. So therefore, clearly, the top becomes like the bottom becomes like the top. That is why we say it's laterally inverted. Your top becomes the bottom of the image. Your bottom becomes the top of the image. That is what we mean by lateral inversion. Now, in terms of letters, if we had, this is the object, this is the image. Now, here, let us conclude that the top of the object becomes the bottom of the image. That is what we mean by lateral inversion, that you had your object in form of an arrow. Now, the top of the object was the arrowhead, becomes the bottom of the image. The bottom becomes the top of the image. That is what we call lateral inversion. You could look at it in form of letters. Let us say you have a mirror there. Then write any letters. For example, we could write something like that. Something like that. Once you reflect, we said the first part or the image should be as far behind as the object is in front. So our letter T will be the first one, because this one is the distance we are talking about here. It should be the same distance there. Therefore, you have your T. Then you have it followed by E. This time you invert it laterally so that its right hand side becomes the left of the image. And then finally you will have letter B in that order. So should you observe your word on the other side of the mirror, you should expect to see something that is laterally inverted. Okay, we have seen that images are being formed, whether they are real or virtual, whatever the characteristics they possess. We have seen that they actually result from the mirrors that we have. Now we want to find out, suppose we had more than one mirror. Suppose we had more than one mirror and we want to form some images. You know, what happens? You incline a mirror at some angle to the other. One image is formed by the first mirror and becomes the object of the second mirror. Let us say, for example, you have a mirror at an angle, probably 45, to another one. What we mean is, we will have an object from this point, have some rays from the diagram, have some rays from the diagram that way. From our object, we have some two rays incident on mirror 1. Now, when this object comes to the first mirror, you expect an image to be formed by the first mirror. Now that one becomes the object, so that now you have them appearing to come from some point here. Now, these rays form the first image. In the real sense, it becomes the object of the second mirror, so that now rays from the second mirror become incident on the second one. Again, an object or a second mirror image here, we call it image 2. This is image 1. And then, if you are somewhere here observing, you will have some rays from the second mirror coming to your eye. And if you are somewhere there, you will be able to observe what is on top here. That you have an object, some rays travel to mirror 1, forming an image that we are calling the first image. This first image behaves as if it is the object for the second mirror. Then the second mirror forms an image that is going to be perceived by your eye as the object. That is the relationship that exists between mirrors inclined at an angle. Depending on the size of the angle of inclination, we have a relationship that actually dictates the number of images that we are going to form. Let us take an example of two mirrors inclined at 60 degrees. Let us call this one 60. So that now we have, or we can start by an angle 90. 90, we have a mirror there, which we call mirror 1. Then we have another mirror here, which we are going to call mirror M2. Then we have an object at this point, which we call O. Now, this object is observed by the first mirror and forms an image M1 by reflection by the first mirror. Now, this image becomes the object that is observed by mirror 4. Mirror 4 forms an image here. We are going to call image I2, which is actually an image of the first image. Therefore, an object was here, was observed using mirror 1. It formed an image we are calling image 1. This image is observed by mirror 4, and for that reason, it becomes an object of mirror 4. Now, it forms an image of itself in this quadrant. Now, this object here is also being observed by this mirror. And now, it forms another object image we call I3. Now, when I3 is observed against this mirror M3, it coincides or it merges with image 2 and becomes one image, because it has to be the same distance behind as this one is in front of the mirror. Therefore, they are going to merge so that now the image of this is at the same position as this one. They merge, they become one. The same case applies if this one was to be observed by this one. Therefore, here we can see if the angle is 90 degrees, how many images do we form? 1, 2, 3. In each quadrant, we have an image. We have 3 images. Suppose we change the angle so that now we have 60. When we have 60, we will have some 6 quadrants. We have some 6 quadrants like that. If this one be 60 degrees, then this other one is 60, 60, 60, 60, 60. The revolution should give us 360. Therefore, we have 6 quadrants. If this be our first mirror, this one is the second mirror. This is mirror 2, mirror 1, mirror 3, 4, 5, and finally we have mirror 6. We place an object here. This object forms an image of itself, which is observed by the adjacent mirror, and again forms another image here, observed by the adjacent mirror, so that it forms another image. Then this one and this one merge to form another one we are going to call 3, because it has to be as far behind as the object is in front. And the same case will apply to this other quadrant, so that this one now becomes a merger of the images that would result from I2. Now, when that happens, you realize that you will have 5 images. If the angle is 60 degrees, now 5 images are formed. Now, I want us to think about a relationship 360 over the angle of inclination minus 1. We think of that relationship. In our first case, we had our angle of inclination as 90 degrees. Therefore, we take theta to be, probably we could elaborate that theta is the angle of inclination. Angle of inclination. So in the first case, we had our theta as 90 degrees. So we took we take 360 divide by 90 and subtract 1. In this case, we can be able to cancel by 91 by 94, so that 4 minus 1 gives us a 3. Now, suppose now we have our angle theta as 60 degrees. Again, we will have 360 over 60 minus 1. This gives us 6. 6 minus 1 will give us 5. When we had our angle of inclination as 90, we made 3 images. When we had our angle as 60, we made 5 images. Therefore, whichever the angle you are given, whichever the angle you are given, the relationship that gives the number of images is n equal to 360 over theta minus 1. Now, where n is the number of images, theta is the angle of inclination. The angle of inclination. That is the relationship that is going to give you the number of images formed by plane mirrors. Somebody would ask you to calculate the number of images formed by mirrors at 30 degrees and 45 degrees respectively. Now what you do, you just take your angle and substitute its value in the relationship that we have just had. In the relationship that we have just looked at, let us try and see what will come out of it. The first one, n will be 360 divided by 30 minus 1. What will that give us? We can cancel by 3, 12, and then the number of images becomes 11. So if you have mirrors inclined at an angle of 30 degrees, you expect that the spectrum would form 11 images. Number 2 was an angle of 45 you take your n to be 360 over 45, and then you subtract 1. If you cancel, this will be 8. 8 minus 1 gives you 7. So you will form 7 images. That is how we calculate the number of images formed by plane mirrors. And it is good to remember always that plane mirrors form their images by reflection, and that the images will always be virtual because rays appear to come from some point behind the mirror, though in real sense they do not. Now, we have some applications of these multiple images that we form using a plane mirror, and one of them is what we call a periscope. A periscope. And a periscope is used. It's actually an instrument used to observe. It's used to observe objects beyond obstacles. Now, we need to appreciate that light travels in a straight line. Therefore, we agreed that when the path of light is obscured, you do not expect to see what is in front here. Rather, a shadow will be formed behind. Now, if an observer was on this side and wanted to observe something beyond this obstacle, then it becomes a bit hard. You cannot observe this object because of this obstacle here. Therefore, you will have to devise a way you can use for you to observe what is here when you are on this other side without necessarily moving the obstacle. Because if you were to observe normally, what you see will be a shadow. It will be a shadow of the obstacle, and that is not what you are interested in. Sometimes the obstacles could be quite big. For example, think of a situation where you want to observe something that is behind a mountain. Now, how can you be able to move a mountain for you to observe something behind it? It is absolutely impossible. And for that reason, we devise a way by coming up with an instrument that will make use of mirrors at an angle and observe something behind this particular obstacle. And takes into consideration mirrors that are inclined at an angle of 45. Let us assume we have a mountain. We have a mountain here. We have a mountain. And then we want to observe something behind here. behind here. So we will have a mirror at an angle of 45. We will have some rays travel to it like that. Then we will have them incident at that point. Of course, they are going to be reflected. We have another mirror we call mirror 2. This is mirror 1. This object forms an image when it is observed via mirror 1. Now that those rays are going to be reflected so that now the image of the first mirror becomes the object of the second mirror. Then the same is reflected to your eye. This is your eye. So you have an object beyond an obstacle. You put a mirror here to form the first image, reflect the same, or rather, the image becomes the object for the second mirror. And now that way, you can observe what you have here at the point where you are. Now remember that we said that a mirror forms an object that is laterally inverted. So now, if you have this object here, it is going to be formed after reflection. It is going to be formed somewhere above here. And it's going to be inverted. When it comes to this point, now it is going again to be erected. So now what you observe will have been corrected because you have double mirrors. So you will see the object as it is. So here we form virtual meaning they are not real images which are actually erect, or you can call them upright images. They are actually upright because it was laterally inverted here. When it comes to the second mirror as it is, then the mirror inverts it again, and now that one will have an effect of giving you an object that is actually upright. Number 2, application number 2 is what we call the kaleidoscope. A kaleidoscope, and this one is used to obtain, it is used to obtain ideas of symmetrical patterns by designers. That designers will use a kaleidoscope to obtain some symmetrical patterns. And this one makes use of multiple images formed by mirrors at an angle. According to the relationship that we have just looked at, 360 over theta minus 1, you will have multiple images formed by this instrument You can use any angle. In our case, we used 60. Sometimes you can even use 45. 45 will give you so many quadrants. Then you have the images. You have the object here. This is your mirror 1, 2, 3, 4, 5, 6, 7, and finally 8. Then the angle of inclination is 45 degrees. You have images by mirror 1 as well as images by mirror 2. So you will have image 1, image 2, image 3. And now we have a merger of the two images so that we can form an image we are going to call image 4. According to the relationship, if you take 360, divide by 45, and then you subtract 1, this one gives you 8. 8 minus 1 gives you 7. So you should have 1, 2, 3, 4, 5, 6, 7 images. And that way, you will have multiplied one image. You will have multiplied an image of this object. So you have 7 other similar appearances of the same, and that one forms a pattern. So this one forms a pattern of the object. For example, in the textile industry, you find that you have some fabrics that have these patterns on them, pattern of the same object repeated many times. They don't just draw, but they will use a kaleidoscope to design that, and that way they can pattern their fabric. We want to look at a few questions with regard to reflection of light. We want to look at a few questions related to reflection of light before we proceed to another property. And number 1, we want to explain how does a person observe something. How does a person observe something? In this case, we talk of an object. How do you observe an object? Now, in this case, we want to talk about it with reference to non-luminous object. A non-luminous object is one that does not produce its own light. So, and we need light for visual perception. Therefore, how do you expect someone to observe an object that does not produce its own light? So this is what we said, that light from a source, falls on the object. Light from a source falls on the object and is reflected into our eyes. That you will have light from some source, say a bulb, a candle, the sun, the stars. Any luminous material produces light. That light will travel to the object. it is reflected to your eyes, and that way you are able to observe. Now, the next question requires us to get the difference between luminous and non-luminous, luminous and non-luminous materials. And on this, we said luminous materials produce their own light. We could exemplify them by the following. You can talk of stars, you can talk of the sun. We talked about glowing worms. We talked about a candle that is actually burning candle, and a red hot material. On the other hand, we have non-luminous, do not produce light. They do not produce light of their own. And we want to give examples as well. And we talk about wood, a book, plastic, your shoe. You could also talk about a bag. Those are things that do not produce their own light. So in your own free time, you can talk, try and state conditions necessary for the formation of annular eclipse, occurrence of annular eclipse. And this one is courtesy of the fact that light travels in a straight line. So we have been able to find out how useful mirrors can be, especially when we want to design our patterns, when we want to observe things beyond obstacle, or when we want to observe things in general, we will have to rely on mirrors a great deal for us to form images. Whether you want a single or even multiple images, somebody would require you to explain how the characteristics of those images come about. We have been able to look at them in details this lesson. Now, when we meet next, we proceed to another property which we call refraction of light as a form of wave. Thank you.